So the last place we left off in lecture was the nomenclature of alkanes. There are a couple different, I would say, common ways to refer to branched alkyl groups. So our first permutation involves 3 carbons as a substituent. And so we can go ahead and number our substituent 1, 2, and 3. And so we know it's a propyl group. Because it's a straight chain, we don't need to associate any additional prefix to it because it's a propyl group. Upon using 3 carbons or more, you start to introduce possibilities of branching. And so the first permutation that's available is one associated with 3 carbons. And the only possibility is an iso group. And it looks like a Y at the end. So we know it's still a propyl group because it's still composed of 3 carbons. But it's iso because it looks like a Y. I want you to note, I want you to put an asterisk next to this in your handout, because this is in your handout, because I do need you to be able to recognize an isopropyl group as opposed to a regular simple propyl group. Once we have 4 carbons, we introduce another level of complexity, and 1, 2, 3, 4 carbons for your straight chain, so it's referred to as a butyl group. We could, instead of having a straight chain, in the same way we saw before, involving 4 carbons, we could have a little Y at the end. And so that is, again, referred to as a butyl group because it's 4 carbons total, but it's an iso because you can see the little Y at the very end. So this is an isobutyl group. Again, no hyphen. Our next possibility is a sec-butyl group. And so it looks like a lopsided Y. So one leg will be longer than the other. We do refer to this using a hyphen in between sec and butyl. So be cognizant of this. This is important to remember for later. And so put an asterisk next to sec-butyl, put an asterisk next to iso. I do expect you to know these. Your last permutation is usually the easiest one to remember for students because it looks like how it sounds. It is shaped like a T. And so we refer to this, and I ran out of space, sorry. We refer to this as a tert-butyl group. You know, again, it's a butyl group because we got 1, 2, 3, 4 carbons, and it looks like a T, so it's a tert-butyl group. When we start looking at 5 carbons, again, we use the same idea. 1, 2, 3, 4, 5. Numerical prefix is pent. This is referred to as a pentyl group. The only permutation I care about that's branched that involves 5 carbons is the one that we've already discussed twice before, and that's iso. We've got 3 carbons, and then you have a little Y at the end. That gets you the 4 and 5 carbons. So again, this is isopentyl. Okay, so let's talk about the rules for nomenclature. As we've discussed in lecture, you simply take the number of carbons in the parent chain, associate with a numerical prefix, and stick ane at the end for any alkane. Rule number 2, you number the parent chain from the end using the closest substituent that has the closest substituent. So you will use the lowest numbers possible. For the molecule that I drew, you don't have in your handout. And again, you don't have the word lowest in your handout, so make sure you fill that in. I have 2 possible numbering systems. I could say 1, 2, 3, 4, simply because carbon 1 is on the left. I could use the white system here, 1, 2, 3, 4, 5, in that way. Now our methyl group, the only substituent present, you have 2 possibilities. It could be carbon number 2 or carbon number 4. Because carbon number 2 is the better numbering system, because it is lowest, you end up using this numbering system overall, okay? For your rule number 3, for substituents with carbons, so carbon-containing substituents, you determine the number of carbons, you apply the numerical prefix, this piece, and then you add YL. This is what we discussed at the end of class on Wednesday. When you have more than one of the same specific substituent, you can use di, tri, tetra, depending on whether or not you have 2, 3, or 4 of that substituent. And so if you have 2 methyl groups, you refer to as a dimethyl group. And for the last rule, you list the substituents alphabetically. This is the only aspect we really didn't cover before the end of class on Wednesday. You have to indicate the location number. You ignore di, tri, tetra, etc. And then sec and tert. Now, sec and tert are 2 of the 3 branched names that I asked you to know. And so I'm going to ask you now, do you remember what the third one was? And if you're thinking ISO, you are correct. So you do not ignore ISO. You have to include the I as part of the alphabetical order. So I'm going to give you a list that you don't have in your handout. And I would like you to order them alphabetically. So here you go. Feel free to pause the video and I'll put the answers up momentarily. Okay, so I'm going to underline for each group the letter you're going to use to determine its alphabetical order. For tert, you ignore tert, so you look at butyl, B for butyl. Propyl is propyl, so you don't have to do anything about that. ISO, you do consider the ISO part of it, and so you don't automatically default to the P for propyl. An easy way to remember it is that for isopropyls, you don't include dashes. For iso anything, you don't include a dash. And so you can think of that as one grouping. So the I for is what you use to alphabetically determine it. But that kind of falls apart when you start thinking about di, tri, and tetra because you alphabetize by M. Now that we have the order, or now that we have the letter we're supposed to consider, let's think about the order in which they should be alphabetized. So B comes first because that's first in the alphabet. I comes next. M is before P. So if I were thinking of the name, it would probably be number dash tert butyl dash number for the isopropyl group. I'm going to have to go to the next line. Dash to whatever the number associated. Oh, and remember, if it's a dimethyl group, you need two numbers regardless of whether or not they're on the same carbon or on different carbons. But then you go dimethyl, then a dash, and then whatever number is associated with the propyl group, dash propyl. And then without having a hyphen or anything else, this is where you stick the parent chain name on. And that is how you order it and the punctuation as well. Hope this helps. These are two molecules you have in your handout that I would like you to name. The only thing you need to know before you're able to name any of these is that this is referred to as a chloro group. It's referred to as a chloro group in the same way that for fluorine, iodine, bromine, and essentially the halogens that we'll be working with this semester, the substituent it ends with an O, as opposed to the YL that is common with all of our carbon-containing substituents. So chloro, iodo, bromo. Because fluoro is one of those substituents people always seem to spell wrong, I'm spelling it out right now. It looks like fluorine, but you replace the I-N-E with an O. So please note the order, the U and the O up here. Okay, so go ahead and name these two molecules. I'm going to provide my reasoning in the name very shortly, so pause the video. So there are actually three different ways you can number this, essentially three permutations that you can number this. So I'm going to do the one that's correct first, in which the carbon bearing the ethyl group gets carbon 1. That's the first possibility. The other possibility is putting 1 on the carbon bearing the methyl group. And the last one's going to just be simply arbitrary. So I'm just going to say 1, 2, 3, 4, 5. Now with the green one, this one's the one that absolutely can't be the right answer, because if you look at your substituent numbers, it's 1, 3, and 5. Both the blue and the pink routes give you substitutions of 1, 2, and 4. So it's got to be pink or blue. And then from here, you have to wonder, well, why is the blue route ultimately the one that's chosen? And it's actually for a simpler reason than you would think. And it's only because since ethyl comes first alphabetically, it's actually the first carbon. It's on the first carbon. And that's why we choose that numbering. But honestly, if this were kind of a question that I present on a quiz or exam, I'd probably take either numbering system because it's fairly trivial. Okay, so the second molecule, go ahead and name it if you haven't already done so. So this is the name of the molecule. We've got essentially two possibilities, but this is the numbering system that applies. And so we have 10 carbons in our parent chain. We have substituents. I've got a substituent on carbon 2, 3, 6, and 8. I already told you 8 is a chloro group, and so I could just say 8 chloro. And if there's a lot of substituents, this might be something that you want to try. We have 6 tert-butyl, and we have 2 and 3 with dimethyl, so 2,3-dimethyl. And because it's hard to be alphabetical and figure out the names and everything at the same time, we know that C comes first. Well, actually, B comes first, then the C, then the M, the dimethyl. And so that's how this name came about. I hope this helps. Your handout should include recommended homework problems from your POGL book. So page 75 to 77, there are a handful of questions that I think are really effective and really reinforcing nomenclature. If you're not comfortable working with the POGL book, you can also take a look at the textbook where you have quite a number of problems to work on nomenclature-wise. So I'm actually going to start with the next video momentarily with constitutional isomers of alkanes. We've already looked at it, but now we can actually apply the name to help us figure out if you have any repeats, okay?